Welcome to Module 4, Lesson 8. Today we have a couple of topics to cover. We're going to start with reviewing equivalent fractions. Now you all have been getting lots of practice with renaming fractions, either when we are simplifying, say we've got 2/4, and we know that we want to simplify that. We want to get a smaller number in the denominator, which means a bigger unit. So this is fourths. If we could get this to a smaller number, it would mean actually a bigger sized piece, and that's what we want to do. And you guys all know at this point that we would probably divide top and bottom by 2. Okay? And the reason we can do this is because 2/2, 2/2, is the same thing as 1. I can divide any number by 1, and I will get that same number. If I divide 2 by 1, I get 2. Divide 4 by 1, I get 4. Divide 2/4 by 1, it's still 2/4. But up here instead of 1, I'm using 2/2, 2/2, which is the same thing as 1, but watch what happens when I divide. 2 divided by 2 equals 1, and 4 divided by 2 equals 2. Now I've got 1/2, which is equivalent to 2/4. They are the same. I can also use that to go the other direction. Say I'm trying to add two fractions that have different denominators, like 2/3 plus 1/6. Okay? I know that I cannot add these as they are, because thirds and sixths are like apples and oranges. I need them both to be the same, to both be fruits. Let's try renaming 2/3 as a quantity of sixths. That way I can add it to the sixth, and that'll be easy. Well, I can look here and think 3 and 6. What do I have to do to 3 to get it to be 6? That's right, I need to multiply it times 2. But if I do that on the bottom with the denominator, I have to do it to the numerator too. Multiply times 2, and I get 4. So 2/3 is equivalent to 4/6. And then you could go ahead and add that. This is all review. You guys know how to do it. I can use that same idea of finding equivalent fractions to express a fraction as a decimal. Now we already know that if we have something like, say, 2/10, that's very easy to express as a decimal, to change this into a decimal notation. Because I see I've got 10 in my denominator, that's tenths. And I know I can write 2/10 with 1 decimal place here. Easy peasy lemon squeezy. However, what are you going to do when you have a fraction like 1/5? Okay, my denominator here is a 5. It's not tenths, it's not hundredths, it's not thousandths. How am I going to get that to be a decimal? Well, what if I made it into tenths? How can I go from 5 to 10? That's right, I need to multiply by 2. But if I do that on the bottom, boy, I better do it to the top, because it's just like multiplying by 2/2, which is 1, 2/2. So it's fair game. 1 times 2 is 2, 5 times 2 is 10, and look, 1/5 is equal to 2/10, which I know I can write as a decimal. And we can do that with any fraction we want. Let's try 1/4. Okay? I want to get this into either tenths or hundredths or thousands or what have you. Okay? Can I easily go from 4 to 10? Is there a number I can multiply times 4 to get 10? Yeah, if you're shaking your head, you're right. I can't do that easily. But could I go from 4 to 100? If you said multiply by 25, you are right, because 4 times 25 equals 100. Think of that as 25 cents. Well, those are called quarters. If I've got 4 quarters, I have $1. So let's multiply the numerator by 25 as well, and we get 25 hundredths, which equals 0.25. Tenths, hundredths. 25 hundredths. So 1/4 is the same as 0.25 or 25 hundredths. I'll show you one more. 1/8. I cannot easily go from 8 to 10. There's nothing I can multiply times 8 to get 10. And in fact, there's nothing I can multiply times 8 to get 100. But I could turn it into 1,000 times 125. If you don't believe me, you can check that. 125 times 8. It works. And I'm really just showing you this example to show that there are a lot of different ways to do it. Not that I'm really going to expect you to pull 125 out of your nose like that. 1 times 125 is 125. So 1/8 is equal to 125 thousandths. 0.125. So the second topic we want to look at today is comparing the size of a product to the size of the factors. Now let's remember that factor times factor equals product. For example, if I've got, say, 2 times 3 equals 6. 2 is a factor, 3 is a factor, and 6 is my product. And normally when I multiply a whole number times a whole number, my product is bigger than either of my factors, right? The bigger my factors get, the bigger my product gets. But we're going to see it's not always the same when you're dealing with fractions and decimals. Let's look at this problem. 4/4 times 12. Okay? Now a lot of you are going to look at that 4/4 and say, oh, that is equal to 1. Because I'm chopping it into fourths and I've got all 4 pieces. So this is 1 times 12, which we know equals 12, because it's 1 times 12. What if I had 3/4 times 12? Would anyone like to make a prediction? Is my product of these two factors, one's a fraction, one's a whole number, is my product going to be greater than 12 or less than 12? If you said less than 12, you are correct. And I can show you that just by multiplying here. I get 36 over 4, which is equal to, that's right, 9. Less than 12. I could also think of it this way. Say this is 12. Okay. I'm dividing it into fourths. I'm only looking at 3/4. Okay, so it's got to be less than my whole thing. When I had a fraction equal to 1, my product was equal to the other factor. Now I've got a fraction that's less than 1, 3/4 less than the whole, so my product is less than my other factor. But is that always the case? Are you always going to get a smaller product when you're multiplying by a fraction? Well, let's try another one. I'm going to slide some of these guys out of the way here. Shoop, shoop. Okay. Let's try another one. Let's look at 5/4 times 12. Would anyone like to make a prediction? Will our product be 12, less than 12, or greater than 12? Well, if you said greater than 12, let's check that out. 5/4 times 12. I know that's just like 12 over 1. I get 60/4. If you divide that, 60 divided by 4, you'll get a nice 15. So 5/4 times 12 equals 15. Well, let's look at our product. It is greater than our factor. Why is that? I thought if we had a fraction, our product would be smaller. than our factor. Yeah, if you figured it out, this guy, this fraction, is greater than 1. If I wanted to draw 5/4, I'd have like a whole divided into fourths. 1, 2, 3, 4. Oh, but I need 5/4. Okay, so this is a whole and 1/4 more. This guy is actually greater than 1. So my product is going to be greater than my factor. All right, let's see if you're following along with us. I'm going to show you 3 problems, and you're going to tell me which one is going to be greater than 1/2, equal to 1/2, or less than 1/2. So 1/2 is the common factor in all these. I've got 1/2 times 3/5, 1/2 times 5/5, and 1/2 times 7/5. Which one is equal to 1/2, which one is greater than 1/2, and which one is less than 1/2? Yeah, if you figured out that this one was equal to, you are correct, because 5/5 is the same thing as 1. 1/2 times 1 is going to be 1/2. If you said 3/5 will be less than 1/2, you are also correct, because this is a fraction less than 1, right? I've got 5 pieces, but I only have 3 of them. 3 of those 5. Less than 1 means my product will be less than the factor I started with. And that leaves 7/5. That's definitely going to make it greater than, because this is more than a whole. I could rewrite that as 1 and 2/5. So it's more than 1, meaning when I multiply it times 1/2, my product will have to be greater than 1/2. If you want to pause the video here, if you're rewatching it, and do these problems, actually multiply them, you can see what I'm talking about. But I think it's pretty clear. So let's apply this idea to decimals. Let's look at a problem like 19.4, so 19 and 4/10 times 0.96, 96 hundredths. Do I think my product is going to be greater than 19.4, less than 19.4, pretty close to 19.4? Let's look at what we're multiplying it by. 96 hundredths. Let's rewrite that as a fraction. 96 hundredths. Is this equal to 1, greater than 1, or less than 1? You're right, it's less than 1. It's only 96 of my 100 units. But it's pretty close. So if I were to actually multiply these two together, these two factors, I would expect my product to be really close to this number. Let's go ahead and try it. It'll give us a good review of this. Oops. 19.4 times 0.96. Now I know when I'm multiplying, the decimals really don't matter till the end. I do all the multiplication. You can follow along with me if you want. 54 is 56. 11. I do all the multiplication. 9 times 9 is 81 and 3 is 84. And then I count my decimal places and put that in. 9 plus 8 is 17. Boy, it'd be embarrassing if I made a mistake here, talking and doing math at the same time, wouldn't it? So this is the product that I get, but I see I've got 1 decimal place in this factor and 2 in here. So that means I need 3 in my product. And let's look at this. 18.624. 18 and 624 thousandths. It's less than 19.4, just as we predicted, because 0.96 is less than 1, but it's not too far off, because this is pretty close to 1. Okay, and you can do that with any decimals. You can make a prediction. How close am I going to be to my factor? Great. So the last thing we're going to do is we're going to try to apply this to a couple of word problems. Okay, let's read this together. During the science class, Teo, Carson, and Dakir measured the length of their bean sprouts. Carson's bean sprout is 0.9 times the length of Teo's, and Dakir's is 1.08 times the length of Teo's. Whose bean sprout is the longest, the shortest? Okay, so there's a lot going on in there. Let's try to break it down. We've got Teo, Carson, and Decuir. And let's look at what they're telling us about these bean sprouts. Carson's bean sprout is 0.9 times the length of Teo's. So we got to figure out whose is bigger there. 0.9. Is that equal to 1, less than 1, or greater than 1? That's right. 0.9 is less than 1. So if I'm multiplying 0.9 times the length of Teo's, I'm going to come up with a product that's actually less than Teo's, less than what I'm starting with. So Carson's is less than Teo's. Let's see what else we know. Decuir's is 1.08 times the length of Teo's. Okay, so is Decuir's the same, bigger, or smaller? Is 1.08 more than 1, less than 1, or equal to 1? Well, clearly, it's a bit more than 1. Only a teeny weeny bit, but it's more than 1. So Decuir's has got to be bigger than Teo's. The question is, though, whose bean sprout is the longest? Okay. Well, it can't be Teo because Decuir's is longer than his. Okay. And yet, Teo's is bigger than Carson's. So the order they would have to go would be Teo, if we're going big over here. Big, little. Teo's is bigger than Carson's, but his is smaller, less than Decuir. Decuir's is bigger than his. So the answer to whose is biggest is Decuir, and the shortest is Carson's. And what was cool about that problem is we really didn't have to do any math. We didn't do any calculating. We just had to really slowly go through the information and think about it. Now I want you to not as slowly go through your practice set and think about it. Raise your hand if you need help. I will be walking around.